Welcome to STRETCHED Unscripted. I'd first like to thank our sponsors, Blue Cross Blue Shield, Intelligent Community Initiatives, and also a big thanks to Catalyst Co-working for allowing us to record a podcast here. So today we're lucky enough to have Dr. Angus Lamar here with us as our guest. And so we're going to kind of jump into things a little bit. Talk a little bit about his background, about his field, and how his field, which is a little different from maybe some of our earlier guests that we've had on this show. He's not actually a healthcare practitioner, but a lot of things that he does help support the medical field and the treatment, eventual treatment of illnesses and diseases and things of that nature. And so with that, I'd like to welcome you to the show.
Yeah, thank you. Yeah, appreciate the invitation. Seems like a fun thing. It's my first pod.
Yeah, right? Whatever that means, right? So, just going to have a conversation. We're just going to talk a little bit about some stuff. I always like to kind of start out by just kind of getting into our guest's mind a little bit and allow them to kind of talk to the audience about them. Mm-hmm. Tell us a little bit about you, your field, your profession, what you do.
It's probably not a totally normal story, but I'm from Oklahoma. I grew up on a farm in a really small town in Oklahoma. My dad was an art professor at a liberal arts college, so that's a super normal upbringing, right?
Yeah.
Cattle rancher and artist and all that kind of stuff. So whenever I was growing up, I kind of grew up in galleries and museums and really wanted to be an artist for the majority of my younger days. And it's probably about, whenever I became aware, I guess, of chemistry. So I'm a chemist, an organic chemist, but it kind of, I wound my way to it through a very strange path. So in high school, I took a chemistry class, and I just liked the fact that I always liked math. So I liked the fact that I could use math in some kind of an application. That was fun. But it was really the first time that I just became aware of science. It was not something that I knew much about at all. And then I went to college and decided I should be pre-med, right? Because I got good grades in high school. So I should be a physician. That's what I thought. And I was pre-med for 1 year. And then in between my freshman and sophomore year of college, I went and did an internship at a hospital. And this was super important for me, just as a human being. So this internship was 5 weeks, 9 to 5, 5 days a week, that type of thing. And I got to see how hospitals work kind of behind the scenes and how the industry, the healthcare industry and everything about it. And at the end of this, I just knew at that exact moment, I would not be a good physician. I don't want to be a physician. I want to help people. But I would much rather hug people than stitch them back together. So this wasn't really my calling. So I knew I had to make some changes as far as what I wanted to do. And that's where I just felt like I didn't know exactly what I wanted to do in life. And it took me several years to kind of wind my way towards where I am now, I would say.
Okay. Can you unpack that a little bit, talk about that journey? Because I think that's something that a lot of our listeners kind of struggle with. High school students, they're trying to figure things out. They're not really sure what they should be doing. They're always, consumed and worried about what their future is going to look like. And we also have a lot of listeners that are in college too as well. And they're kind of in the same boat. They come in, freshman year, they're thinking pre-med, pre-PT, OT, whatever it is, right? And then they kind of get going and they shadow or they do an internship or something, and they're kind of like, hey, this isn't exactly what I thought it was going to be. what do I do now?
Yeah.
And so for you, what was that journey kind of like? How'd you just kind of move into this?
Oh, well, yeah. I think a big part of it for me was that I was never certain about my path at any point. I mean, I never decided this is definitely what I want to do and this is where I want to head, and then just everyone get out of my way. I'm going to get there, you know. I think I kept my options open, and I was very aware of the things that I was interested in and the directions that I was kind of going in and what I was actually, like I said, sort of interested in. So all the way up until college, I really always thought I was going to be an artist. I mean, that's what I was always interested in. And it turns out that in order to be a good artist, you have to have talent. So that's what really like steered me in another direction. I like the process of creating things. And that's probably where I found some maybe common thread in chemistry, which you may not normally see chemistry and art as being super similar fields, but I kind of started to see that in even back in high school, and I guess I didn't realize it totally, but I kept my options open, and I was just open to whatever it was I was interested in. But you know, in chemistry, you've got all these different elements, and the way that you combine them together, you can create something that didn't exist before, and it has an application, it has a purpose for whatever it is you're doing. And I thought that was really similar to art. You know, you've got all these different colors and paints, and you mix them together in some new and unique way, and you put it on this blank canvas, and you can turn something that wasn't there before into something that is now there, and it has some effect. Right?
Yeah,
it has some
definitely,
purpose, especially for a viewer. So I think I saw that common thread, but this was like art with math, and I liked math,
Mm-hmm.
you know. So it was fun, but I still wasn't necessarily just fully sold and gung-ho about chemistry. So after I changed from pre-med, after my first year, my sophomore year, my plan was that me and another guy were going to open a T-shirt shop on a beach. That's what we were going to do.
There you go.
So obviously that didn't happen. So my third year, my junior year of college, the plan was then to become basically like a forensic scientist, but in an art museum. So there's conservation science. That's actually a field. You can get paid to do that. And I thought that would be like the most fun thing in the world. You'd go to work every day in a museum around art, but, you know, I wouldn't have to actually try to make art. I would just tell if something was a forgery or if it was authentic, and use instruments and use chemistry to do that. So that was my plan junior year. And then in between my junior and senior year, I had another really eye-opening experience. Again, just keeping my options open. I didn't know what I liked. I didn't know where I was headed. But in between my junior and senior year, I did a research experience for undergraduates, RU program at OU, at University of Oklahoma. So for 10 weeks, I was in a research laboratory. And that experience for me was completely, like I said, eye-opening. At that point, I knew I wanted to go to graduate school. I wanted to continue doing this research thing. That was kind of exciting. Instead of just reading about, you know, what other people have done, you're kind of creating new knowledge, and that was super, super exciting. So it really wasn't until my senior year that I started to have some solid direction about where I wanted to go. I knew I wanted to go to graduate school, and I knew I wanted to teach at a university. So originally I was thinking a 4-year, like a liberal arts college, like where I went to college.
Yeah.
But the more research I did in my PhD program, and then after my PhD, I went to a postdoctoral research experience at Emory University, and did a lot more research focused on, I would say, things that are medicinally relevant. Things that are relevant to pharmaceuticals and stuff like that. And that kind of, it brought me back to that other interest I had, which is people's, you know, healthcare. So I've always been interested in healthcare and in creating new things and in art in a lot of ways. So I didn't know that there was going to be a job specifically for that, But in a lot of ways, what I am now, it's kind of come full circle for me where, I teach an elective course about chemistry of art conservation. I teach medicinal chemistry. So this is chemistry of pharmaceuticals. And I teach organic chemistry to a whole lot of pre-meds, right? So just because I didn't become a physician doesn't mean that I'm not interested in still helping future physicians get to where they want to go. And then they can help people. So I can sort of tangentially help people in their health in that way. But, through the research, too, since we tend to focus on some of these things that would be relevant to pharmaceuticals, I can still kind of explore some of those areas, like I said, in totally different ways than a physician would. Yeah.
Very nice, very nice. So let's talk a little bit more about your research. Can you tell us a little bit just what it is that you research, and tell us a little bit about potentially the application that it could have to the medical community. Keeping in mind our audience is high school students, and
Absolutely.
We got some college as well. But yeah.
Yeah, so I'm an organic chemist, and there's a lot of different ways that you can do organic chemistry. But sort of the subset that I probably fall into, or maybe most interested in, is the discovery and development of new organic reactions. So kind of the way that I've always
So tell us what an organic reaction is.
So organic reaction is if I want to transform a chemical or a molecule, or at least a part of a chemical or a molecule, into something else, I need a reaction in order to do that, right? I need to change this part into that thing over there. So kind of the way that I've always thought about it is if you want to completely, synthesize or make a drug, right? That's what the drug companies do. They make these really complex molecules. If you wanted to make one drug, it may take a really long time. The drug discovery process, it takes 10 to 12 years from the conception to launch, and it takes about $1.5 billion
Oh, wow.
In order to get a drug to market, right? So if you're going to synthesize a drug and then take it through that process, you better not miss type thing. So either you can spend a lot of time trying to make that one drug, right? So, and I kind of view it like building a house. There's a lot that goes into building a house. But what I'm really interested in is sort of those individual reactions, those transformations to change this thing into that thing. So it's almost like if we were to create a new tool. What we do in our lab, it's the equivalent of like creating a new type of saw that everyone that builds houses can then use our saw to build their houses. Okay. Right? So there's a lot of different organic reactions which essentially would give us ways to transform certain parts of molecules into other things that show up in drug molecules really frequently. And some of those reactions either don't exist, right, currently, so we've created new ways to do this, or maybe it takes like 4 or 5 different steps in order to get there. It's really long and it takes a lot of money and a lot of time. And we've turned those types of processes into ways that you could do this in one step. So it's direct and really inexpensive and it's really fast. So it's trying to provide new tools for people that would be interested in making drugs.
Okay, cool. Now, you recently were awarded a grant. Could you tell us a little bit about that? Just kind of speak to that just a little bit. Tell us what that was about, how much it was for, and what exactly are you being funded to research?
Yeah, so this grant was from the National Science Foundation, NSF, and it's over the course of 3 years, we get $500,000, so $500,000 to essentially try to develop these new tools. And we've kind of come up with this really, I would say, it's an unusual way to make molecules that even though we've been working on, certain types of compounds and drug molecules for 60 years, 80 years, 100 years, a lot of advances have been made, but there's still certain things that you just can't do very well. So we really focus on those areas. And we found a pretty unusual way to install a certain type of functionality, a functional group, into certain locations of these molecules. And I thought it was really bizarre that this hasn't existed. This doesn't exist, right? But we found a super easy way to do it. So essentially, what this means for us is that we can make, and this is kind of what we do in our lab too. So we find these new tools, these new ways to make molecules you couldn't have made before. And then we make what we call a library. So we make like 30 or 40 different types of these compounds, these molecules, that are slightly different in different places. And then with our collaborators, like Dr. Robert Schief, who's a biochemist at University of Tulsa, we just walk our compounds down the hall, and he'll tell us whether or not they have biological activity. So he's a cancer specialist, so he tells us whether or not they have anti-cancer activity. So basically, part of this grant was that we're going to be able to make compounds that have just eluded everyone for 100 years. You just couldn't make these things. So we're going to be able to make these, and then we're going to find out if they have biological activity, because they look like drugs. They look like pharmaceuticals, and we can make them in one step.
Nice.
So if they have anti-cancer activity, then we'll continue to sort of pursue some of those and see if we can make them as good as possible.
So is that the main focus of these things that you're developing is really to help ultimately develop effective ways for treating cancer?
Absolutely. Well, I should maybe not the cancer. So again, I think what my main interest is in just developing new reactions that people could use to make whatever drug they wanted.
Whatever.
And whenever we make these new compounds, the reason that we found that they have anti-cancer activity is because Dr. Schief is a cancer specialist.
Okay.
So he's looking for anti-cancer activity.
Uh-huh.
For all I know, we have antibacterials and we have Alzheimer's drugs, and
So it could be a
who knows?
combination of things.
Exactly.
Yeah.
This is just what we've been testing.
Okay.
These compounds for.
So it kind of opens the doorway to be able to really to address a lot of different diseases and conditions,
I hope so, yeah.
not just cancer.
And in fact,
Nice.
Over the years, with some of these libraries that we've made, so one of our libraries, for example, has shown really selective activity against brain cancer. And part of that is that we based it off of a known Alzheimer's drug, and we modified it using our reaction. And then we have a bunch of compounds that can actually make their way into the brain, which is a really difficult thing to do for drugs. It has to cross what's called the blood-brain barrier.
Yeah.
But once they get in the brain, then they actually selectively target brain cancer. So we have a patent and several publications and things like that where we've made these types of compounds to target brain cancer. And we have a whole bunch of other compounds that we've made in a library that target pancreatic cancer. But again, I think my initial goal was never to make a drug to target pancreatic cancer. We made a bunch of compounds, and it turns out that we kind of got lucky. This is the application, the effect that we've observed they have. And then once we knew that, then we really went back in and we started to modify these compounds with some purpose to try to make them even better at killing those types of cancer cells.
Great. So I kind of want to switch gears just a little bit. Because you're obviously very accomplished. PhD from OU, did your postdoc at Emory out in Atlanta. Along the way, do you feel like there were certain obstacles that you had to overcome? And if so, who were those key individuals or that key individual who kind of helped you along the way?
Oh, yeah, I guess everybody always faces some kind of a barrier otherwise it was too easy, right? I mean,
Oh, yeah.
So I think the biggest thing for me was, so I went to the small college that my dad taught at.
You said that's in a town in Oklahoma.
That's in Oklahoma. It's a liberal arts college called University of Science and Arts of Oklahoma.
Okay. What city is that?
It's in Chickasha. So
Okay.
I grew up in just outside of Chickasha in a small town called Verdon. So this is like a rural farming community. I graduated in class of 20.
Okay.
From high school, so a small place. But whenever I was at USAO, I wouldn't say that I was a particularly great student, and I made perfectly great grades, but I don't think that I was a good student in the sense that I didn't retain information in the way that I probably needed to. I would study, the night before a test, and then I'd take the test and I'd do great on it, and then like the next day I'd be like, I don't remember. So kind of what happened to me was whenever I started in graduate school, I was actually expected to know a whole lot of chemistry that apparently I had learned, and I just didn't remember any of it. So graduate school's tough. So you have to take these exams called comprehensive exams, and you got to I had to know everything there was to know about organic, and that's
It's a lot.
Yeah, it's a tall order. So I think what was hard for me, the biggest challenge that I had to overcome was I had to learn how to become a good student. I had to learn how to really learn things and store it into the long-term memory and retain it. But I think what helped me turn that corner was just, number one, seeing everyone around me that they were so mature about it and professional about being in graduate school. And I kind of saw them, my peers, lab mates, and older students that were there. I saw that, they were treating this as their career and not just like, hey, you're in class, go take a test because some professor asked you to know something. This was, hey, give me the information. I need to know this for my career, and then get out of my way. I'm going to know it. So I think probably in my second year of graduate school, and third and fourth and fifth, I had to mature a lot. So that was probably the big barrier for me, was just me getting out of my own way and really kind of learning how to learn better. And I see our students at TU, they're going through a lot of those lessons and things like that as undergraduates, and I just think, man, you guys are so far ahead of the game, you know, where I was at. But and maybe it's just how rigorous the university is compared to maybe where I was or something like that. But I think that was probably the big thing for me, was trying to figure out that I needed to know this stuff, not because someone else expected me to, but because I needed to know it for my career. If I want to be really great at this in the future, then give me as much information as you can, professor. Yeah. And then, you don't need to worry about whether or not I learned this trust me, I'm going to learn it. So, that was probably the big thing for me.
Okay. So you touched on a couple things there. If there was one thing, parting thought, parting phrase that you feel like you would want to share with our listeners, maybe it's something that you personally came up with, but it could have been something someone, a mentor or whoever, shared it with you, and it's just kind of been your mantra, and it's just kind of helped, have been kind of that compass for you. Yeah. Help you find your north. What would that be?
For me, it's always been kind of, I guess, pay attention to the things that you're interested in, and don't try to talk yourself Don't use your brain to talk yourself into things sometimes or out of things. I think for a lot of those big decisions early in life, I really did trust my instincts and my gut. And what I've learned is that your gut is probably right about most things, and your brain may not understand why it's right, but 10 years down the road, you can make sense of why it was right. So I would say keep your options open and really pay attention to what it is that you're interested in. Whenever I was a freshman in college, I was pre-med, and I was in biology classes and chemistry classes. And whenever I decided to not be pre-med anymore, I completely dropped the biology thing and went to chemistry. And it was because I liked the topic of biology. I found it interesting, but I didn't really like the process of learning biology as much as I liked learning about chemistry. So it was a lot of memorization and stuff like that. So I kind of paid attention to the things that I like to learn about and not just the topics. And that steered me then. And then I just kept my options open, trusted my gut, because, again, I think your brain, you can always find reasons to talk yourself into something or out of something, but you always kind of know in your heart where it is you should steer, and trust that. You're gonna it'll all work out 20, 30 years, and you'll look back on it and say, I made all the right decisions somehow. I don't know how that happened, but here I am. It's kind of what happened with me. Even with research, I mean, I didn't ever intend to make drug compounds. I wanted to just do organic chemistry, but whenever things start to work and you sort of see where things can lead you, be open to things leading you in those directions, and be open to changing and adapting.
Awesome. Dr. Angus Lamar, thank you.
Thank you.
Thank you very much. Yeah. Again, I'd like to give just a big thanks to our sponsors, Blue Cross Blue Shield of Oklahoma, Intelligent Community Initiatives, and again, Catalyst Co-working, located on 15th Street here in Tulsa, Oklahoma. If you ever find your way out here, they also have a nice coffee shop, Bryce's Coffee Shop. And grab yourself something to drink and get some work done. Again, Dr. Lamar, thank you for joining us.
Thank you.